Here is the thing that I love to cut the most, both in gross lab as well as in histology lab. It is the spinal cord. Spinal cord is beautiful. It's basically simple as well, no matter what level you cut at. Even though you may cut it at various levels and see various types of patterns, it's basically all the same. You have centrally an area which are rich in neurons, which are called gray matter. And then more peripherally, you have areas which are very absent in neurons, and that's called white matter. And the gray matter has a posterior or dorsal aspect and an anterior or ventral aspect. And the posterior part of the gray matter is mostly devoted to sensory functions, and the ventral part of the spinal cord is devoted mostly to motor functions, and we have motor neurons. The white matter of the spinal cord are chiefly various tracts that either go to the brain or come from the brain. In other words, ascending or descending. And the central portion of the spinal cord looks like it has a little hole lined by epithelium, but in reality, this is a central canal, and it is lined by ependymal cells, which is the only type of glial cell we have not identified yet. And as soon as this comes into focus, you can start to see ependymal cells lining the inside of the central canal of the spinal cord, just like they line the entire ventricles and choroid plexus of the larger ventricular spaces of the brain. Let's go back and say a few things here. Just like we saw in the central nervous system of the brain, we had large cells called neurons, and we had small cells called glial cells. And then we had vascular spaces, membranous, loose connective tissue, and very, very vascular tissue called arachnoid mater. And then we had a couple tiny little cells just covering the surface of the central nervous system called pia, which we may find in here. But all of this is arachnoid, all of this is arachnoid. And these nerve fibers out here are either dorsal or ventral or anterior or posterior roots of the nerves, and that's what's to be expected. And they aren't like any other nerve. They are nothing more than Schwann cells surrounding axons. Let's go into a part of the spinal cord and review what we've already abundantly said for the other portion of the central nervous system called the brain. These large cells are neurons. The small cells surrounding these large cells are all glial cells. Here's a bunch of neurons, here's a bunch of neurons, here's a bunch of neurons, here's a bunch of neurons. And the tinier cells, which we will see on higher power surrounding it, are glial cells. And then all of the cells surrounding this, the various tracts of the spinal cord, ascending or descending, are nothing more than myelinated axons or dendrites. Myelinated axons, only in this case, the myelination cell is an oligodendrocyte because it's in the central nervous system rather than a Schwann cell like we see myelating nerves in the peripheral nervous system. Here we are, higher power, some beautiful multipolar neurons. Look at how they extend their cytoplasm. If the extension part of the cytoplasm stops abruptly of Nissl substance, then that is clearly an axon, whereas Nissl substance will go clearly into dendrites. And whether we'll be able to prove that on this type of microscopy or not, I don't know, but let's click up one more notch and maybe we'll get lucky. The reason why you can barely see the nucleus within these large somas of the neurons is that it's totally obscured by Nissl substance. Classically, if Nissl substance would stop abruptly and then you see cytoplasm coming out of that, that's more likely to be an axon because Nissl substance extends into dendrites. All of these smaller cells surrounding these are astrocytes and oligodendrocytes. Maybe if you see a real small one like there or there, that could very easily be a microglial cell. And a good rule of thumb is that not only are neurons 10 times bigger than astrocytes, but they're about 1/10 as common as well. And another rule of thumb is that if you could actually see the nucleolus of the nucleus of a neuron, it'd be about the size of a whole nucleus of a glial cell. Notice how we have an abundance of fibers throughout here. And then notice how there's a rather abrupt transition, and all of a sudden you're into an area in which there are no neurons, but nothing but the predominant cell being these cells which have a lot of white washed out myelin around them, and these are predominantly, if not entirely, oligodendrocytes, which are the insulation cells of the glial cells of the central nervous system. Is there anything more we want to say about spinal cord? I don't think so. I don't think it's really good to get into all of these esoteric names if you just want to describe the basic histology, because you're not going to get anything from it. Well, I think what I want to do, because we didn't see the ependymal cells on any of the other slides, let's actually come in here and zip up this central canal of the spinal cord. And we can show you that these epithelial-looking cells, which apparently are lining a very small lumen, are indeed your classical ependymal cells. And they are the only type of the 5 types of glial cells which look pretty much like a simple columnar epithelium. These line the entire ventricular system as well as the surface of the choroid plexus, which makes the cerebral spinal fluid. And now, I thank you very much.